Hey, it's Mr. K, Physics 30, Unit B, Part 1, Review, Numeric Response 6 and 7. Doesn't that look like projectile motion? Well, it does to me. The question's asking me what is the horizontal distance traveled, and I know I can't just measure the plates. Although, wink, wink, nudge, nudge, on the test you will have to measure the distances with your actual ruler. Bring a ruler. Okay, secondly, from here, there's a couple different ways to do this, I'm sure, but here's how I did it. Now, realizing that this electron is going to be accelerating in the vertical and constant velocity in the horizontal, I wanted to figure out as much as I could about that accelerated motion. So I found the force. Q times electric field, which is delta V over delta D, tells me the force that is pushing this electron, or pulling it, depending on how you look at the world, toward the positively charged plate. Looking at my FNet statement, the only force responsible here, ignoring gravity at these small values, is 5.44 times 10 to the 14 meters per second squared. So Fe is my only net, or the only force acting, so it is also my net. Mass times acceleration, find my acceleration. Okay, and then lastly, for projectile motion, I'd usually split this like x and y, but due to space requirements or limitations, here I've dealt with it in the y first. So I know the distance it traveled was 2 centimeters. I know that the initial velocity in this direction was 0, because it's going horizontal. There is no vertical velocity yet. And then 1/2 at squared. I know acceleration, because I just found it. I'm going to find time. What we should remember from projectile motion is that the one thing that is the same horizontally or vertically is time. It's the same object, it leaves at the same time, it hits the ground at the same time. So I find the time it's in the air, which is a ridiculously small amount of time. And then looking at the horizontal, this is all uniform motion here. So I can use V equals D over T. I do that and I get my 7.71 centimeters. Just to cover projectile motion key ideas again, if you will. In the horizontal, this motion is uniform. In the X, I started from rest in the horizontal, and then I essentially accelerated in the horizontal, in the vertical, excuse me. So uniform in the horizontal, where I'm going 9 times 10 to the 6 meters per second, and the vertical, I found my acceleration. I started at rest in the vertical. I know my distance in the vertical, found my time, found my distance. Last thing on this question, it also asks me which physical principles I use, or physics principles I use. Now that's looking here on your formula sheet. Now the way I did it was, I realized that in the FNet was not equal to 0 first, and I found the acceleration using an FNet statement. And then I used uniform motion for the horizontal section where the velocity wasn't changing. So I chose 1, then 0. Very typically, they also would accept 0 and 1, as different people could algebraically do different things. Thanks a lot for tuning in. Projectile motion. Super fun.